So the Board of Studies expect the hypotenuse, adjacent and opposite sides with respect to a given angle in a right angled triangle of any orientation be shown to the students, and that's what we'll go and do. So lesson 1 does that. It identifies the hypotenuse, adjacent and opposite sides with respect to theta. The board then requires that the labelling of the side lengths of a right angled triangle in relation to the given angle, e.g. side C opposite angle large C, and recognise that the ratio of matching sides in similar right angled triangles is constant for equal angles. And here is the second lesson addressing those points. The board requires that sine, cosine and tangent ratios for angles in right angled triangles are defined. The students know about that, and using the trigonometric notation such as sine A. And this is lesson 3, defining sine theta as opposite over hypotenuse, etc. for cos A and tan A. The students are then required to use calculators to find trig ratios for a given angle in degrees. Use the calculator to find the angles in the nearest degree, given one trigonometry ratio of the angle. And they're also required to select and use appropriate trig ratios in right angled triangles to find unknown sides, including the hypotenuse. Selecting and using appropriate trig ratios in right angled triangles to find unknown angles correct to the nearest degree. So basically the students have to learn how to use a calculator to calculate those degrees in minutes given the ratio of the sides. They have to be able to find an unknown side of a right angled triangle. Given that the angle is measured in degrees in minutes, they have to go back from there using the calculator or any other method. And they need to use the trig ratios to find unknown angles in degrees and minutes in right angled triangles. So basically my lesson 4 takes care of all of that. It's quite a bit of work here, so we'll just go through it. Most of the students will be using a Casio calculator such as this. There's an emulator available, so you can put it up on the screen, the big screen, and push the buttons with a mouse. That's quite good for them to understand how to use their own calculator. So lesson 4 basically is a double period at least to cover these calculator problems. Here we have a part of an angle that has to be turned into minutes, degrees. So you can see here that the students are introduced to some of the nomenclature of trig, such as angle B, triangle ABC. Those symbols are important to know, and perpendicular. They need to know that as well. Well, lesson 4 gets complicated a little bit because it introduces the inverse trig functions to the students, probably for the first time. They'll have to get their head around the use of the function, and I will be going through the use of the function and not the definition, because I think the definition, elaborating on it, will just confuse the students more. The cos and sine of right angled trig functions are complementary. The students need to know that. That's what the board requires. So the lesson 5 covers that material, plus it's a natural extension into the reflex angles 180 minus theta. So I introduced the students to a little bit of extended work in this lesson, in case they choose, some of them choose to go down the extended path from Year 9. So lesson 5 then goes through all stations to central, and that'll give the kids a chance to remember which trig functions are positive in which quadrants. And just a couple of examples there of those complementary functions. So my lesson 6 is concerned with bearings and angles of elevation and depression. The board for some reason is insisting that that goes above, that they list it above the some other parts of the trig, but I've always been taught that that's the way to do it. Put it at the end. It makes sense to go at the end. So I've changed the order. And this is the end of lesson 6 and the end of the unit of work, where they're working on problems of real life bearings and angles of elevation. The later worksheet that I produced for the unit of work goes through a heap of exercises and examples, word problems, etc. on all of that unit of work. And that's it.